So what we'll be speaking for next 45 minutes, something like that, is about doing continuous delivery, doing it in a way that might be different than what you're used to. It will be serverless, even though probably serverless not in a way how you perceive serverless. And I'm going to show you quite a few things, but the most important part and focus of what I'm going to try to show you is ChatOps, right? How can we combine continuous delivery with GitOps, ChatOps, and a few other principles? So I'm going to skip this part because this is, I executed this before I started. This just created my cluster, in this case GKE, but everything I'm telling you today applies to any Kubernetes cluster, no difference whatsoever, right? So any Kubernetes, who is using Kubernetes here? Okay, cool. Okay, that's nice. That's a nice percentage. Okay, so this is how I look like. My name is Viktor. I work for a company called CloudBees. We have a couple of products. The one that you're most likely used to is Jenkins. We have others. What else? I'm one of the Google developers expert. I'm one of the Docker captains. So you can probably guess that my focus is usually around, on one hand, containers, microservices, Kubernetes, CI/CD, and stuff like that. I have a blog, I have books, I have more books, I have a podcast, and I have Twitter. That's everything you need to know about me. So, going serverless. Before I show you actually how it looks like today, any of you using Jenkins? Cool. Oh my God, that's a lot. Excellent. So, it's a very commonly used tool. I'm not selling you anything today, so that's okay. So the idea behind Jenkins, even though most of you are probably not implementing it like that, is that you have some Git repositories, you change something in those Git repositories, and Git triggers something in Jenkins, and Jenkins builds something, or runs tests, or deploys it, right? The whole idea, even though many people are not implementing it like that, is not for you to click buttons in Jenkins, but to push something to Git and let Git notify Jenkins to do something, right? Whatever that something is. That something can be many different things. Now, so Jenkins is running a lot of different, we call them builds. It's not really building software. It's builds can be anything, testing, deploying, whatever it is, right? A lot of tasks. Now, for Jenkins to do that successfully, to be able to manage a significant load, we don't do any of those tasks inside of Jenkins. We spin up build agents, right? Since we are all living in Kubernetes eras, many of you, at least, all of you at least know what are containers. Many of you are using it. Those build agents today are containers managed by Kubernetes. So if you have 1,000 builds going right now, you would have 1,000 pods spin up across your cluster. They would do stuff, and then they would disappear. So far, so good. Now, the problem comes when you grow beyond being a relatively small organization, right? What happens when you need to scale Jenkins, right? Sooner or later, Jenkins will hit its limits. Maybe you did not experience those limits if you don't have a lot of things going on, but every application, Jenkins included, has a limit of what it can do by a single replica. So what we've been doing so far is that when you hit those limits, I don't know, maybe 1,000 concurrent builds on average, or something like that, or 10,000, 100,000, whatever the number is, you would spin up a second Jenkins master, right? And then you would have 2 Jenkinses, maybe 3, maybe 4. I've seen organizations have hundreds of Jenkins instances running across the cluster. And that's how they manage scale. That's how they manage to do the job that they need at a very big scale. Now, problem with that, there are a couple of problems with that, and really important and huge problems. Maybe even problems that cannot be even solved with Jenkins. And one of those problems is, first of all, that having 2 Jenkinses is not the same thing as scaling Jenkins to 2 replicas. You cannot scale Jenkins. It is physically impossible. You cannot have 2 replicas of Jenkins. You can have 2 instances, which is a completely different thing, right? Simply because it was designed 15 years ago. Another problem, huge problem, is what happens when it fails. What happens when it goes down? What happens when a node goes down? What happens if the whole data center goes down? You will have downtime, right? And this is not only Jenkins. This is any application that cannot scale will go down sooner or later, right? It is impossible to avoid downtime if you cannot scale your applications. That simply defies laws of physics. So what happened now, luckily we have Kubernetes today, so when Jenkins goes down, you have downtime of only maybe 2 minutes until Kubernetes puts a new instance of Jenkins somewhere else. But still, downtime is downtime. So what we've been doing for the last year and a half, more or less, we've been designing a complete replacement of Jenkins, something that will completely replace it with something else. To do that replacement, first we figured out it's going to be only for Kubernetes. We're not bothering anymore with things that are not Kubernetes, not because it's not important, it is, but there is already a good solution for non-Kubernetes tasks, right? Bunch of applications do that job well. So we focused on Kubernetes and thought, okay, so we need to accomplish that our applications, our solution is scalable, fault-tolerant, highly available, that it doesn't occupy more memory and CPU than needed, and so on and so forth. Bring it to 2019. And to do that, we decided that we are not going to write everything from scratch. We are going to adopt some tools and wrap them around with some custom code to make them useful. And those tools that we have today is Prow. I don't know if any of you are familiar with Prow. Okay, so if you're not familiar with Prow, that means that none of you ever contributed to Kubernetes project itself. Because Prow is used by Kubernetes project to do their ChatOps and to be entry point for webhooks and some form of CI/CD. I'm going to show you Prow actually very soon. Then we said, okay, look, there is nothing really in Kubernetes, there wasn't anything in Kubernetes a year and a half ago that is useful for CI/CD processes, right? There is no such thing as a Kubernetes resource that can do those types of things. However, in the meantime, a new project started and it's called Tekton. Tekton does not really matter which solution you will use for CI/CD, most likely that solution will be based on Tekton. If you use Red Hat this, or IBM that, or Azure this, they're all CI/CD solutions in the future are most likely going to be based on Tekton. That is going to be golden standard of how we do CI/CD. And I'm not selling you anything, this was not done by me. So this is done by, in this case, started by Google, now adopted by everybody. And then we built something that we call today Jenkins X on top of those two, and many, many others, but those two main components. So what I'm going to do is that I'm going to show you very soon how that looks in practice, part of it, because it's really huge. But before that, the new architecture looks like this. We have Prow, we have pipeline operator, and Tekton pipelines. All those things, when they're idle, when nothing is happening, are occupying maybe 50 megs of memory. That's all. Unlike traditional Jenkins that can occupy anything between 2 gigabytes and 200 gigabytes, depending on the scale of what you're doing, right? So this is extremely lightweight, extremely scalable solution that can work for anything. So Prow is in charge of accepting your webhooks from your Git, right? GitHub, GitLab, whatever. Accepts webhooks and chooses to do something. That something can be go back to Git and merge a pull request, for example, or it can be go to the cluster and notify some component in your cluster to do something. And that component is pipeline operator. That one translates your YAML files into pipelines, right? What is a pipeline? That's a separate story, but all the tasks, everything you need to do with some application is going to be translated by this guy, and then it creates Tekton pipelines, which is very, very low-level CI/CD potential standard in Kubernetes of sorts. So what I'm going to do is that I'm going to show you how part of that works. I don't have enough time to go through all that it does because it does a lot of things. So I'm going to focus on ChatOps, right? Anybody knows what is ChatOps? No? Okay. GitOps? GitOps is easy. Only Git can initiate some action that will result in a change of the state of your cluster, right? Or to put it in other ways, GitOps means that you don't have buttons to click anymore in some UI when you want to do something. You want to do something, you change source code, you push it to Git, and Git notifies your system to do whatever needs to be done to converge the desired state into the actual state. Now, ChatOps is a way to operate all that by writing comments, by writing texts, right? And the reason for that is that we have two seemingly separate things that we are doing today. On one hand, you're writing some things to leave the trace of what you're doing. You might write today, right now you can go to your PR and say, hey, John, can you please review this PR for me, right? That's information. Or this is horrible, never do this again. That's information. But part of that information, part of that communication that you're doing with your colleagues should be translated into some actions. If I say, John, can you review this PR for me? That PR should be automatically assigned to John. If I say, this looks great, write a comment, this looks great, we can move forward with this pull request, it should be automatically merged to the master branch and probably deployed to some environment and so on and so forth. So the process normally in everybody, I mean, probably 98% of you are doing the same thing. And that same thing is that you're creating, you have some feature branches, you're working. You push that to Git, you create a pull request, you validate that pull request automatically. You're running some tests, you're building some application, you're doing something automatically. And then you probably assign it to your colleagues for review, right? Some companies do that because somebody acts as a policeman. That's not what I'm referring, but simply you want to have a shared knowledge from the rest of the team. What is this about? And then you probably validate it sometimes manually. I would love to live in a world where everything is fully automated, 100%. No human interaction no human actions after pushing something to Git. But in reality, in most cases, you will have some kind of manual validations as well. And then you will speak with your team and communicate about potential issues. Maybe you should have done this. Maybe you should have done that. How about this? This is horrible. Were you really drunk last night? Because otherwise you wouldn't do this, right? There is some kind of communication about issues. And when there are issues, you would fix them and repeat the process again, right? Everybody does this. I mean, more or less, with some variations, unless anybody on SVN is still. Okay, so everybody's doing this. And when there are no issues, you approve the pull request, and approval of a pull request means that it is merged to the master and it is ready to initiate the process that will ultimately lead of that feature being deployed to production. Okay, so what we want to do with those pull requests, we want to document communication. That's why we're writing comments. What happened here? That's not what I wanted. Okay. That communication is triggering some actions. Approved, that's an action. Notifications leads to, those notifications are leading to some actions, whatever those actions are, and usually done with people who have certain privileges. By that I mean maybe everybody in your team can merge a pull request, but people who are not working in your company cannot, and so on and so forth. There are always some privileges. So most of those things are already solved problems. You know how to write comments in Git. There is no need for anybody to bring a new solution for that. Git is already notifying you whenever there is a change in a repository. No need for anything new. Authentication is already handled by Git again. The only thing that is missing is how to do those actions and how to do them really well. And that's what I'm going to show you now. So, very quick demo. So what I have here is a Kubernetes cluster with Jenkins X running. Nothing else, not even repositories. So I'm going to start a new project. I'm going to show you how that looks from a very beginning, from the start. So I'm going to create a new project. And if you look at the comments, arguments, you will see that project is going to be called JX. Do you see this? Is this big enough? Okay. It's going to be called JX Pro, and it will be based on Go. Anybody using Go here? Okay. Shame on the rest. Be ashamed, please. It's not COBOL, at least, right? Not many. How many of you are working in a bank? So there is COBOL. Okay. Okay. So I'm going to create a new project. I'm going to start from scratch. Right? Imagine that we are starting a new application right now. Okay, this is not what I expected from this demo. Okay. Okay. So the system said, okay, so if you want to work in Go, you will need a bunch of stuff, right? You will need some source code, some hello world that you will continue developing. You will need to build Docker container images, so you probably need Docker file. You will need to package that application somehow, and since you're using Kubernetes, most likely you're going to use Helm. You're going to need to figure out how to build and deploy at the same time, so you're probably going to use scaffold and so on and so forth, right? So it made a lot of decisions. You can change those decisions yourself, and my project is all already ready to be used. And I will show you that. Basically, these are all the files that it created for me. There is a pipeline, there is Docker file, there is make file, there is whatever I need for my project. And that will depend from one language to another, from one framework to another. Every language will create different stuff, right? But that's not what I want to show you. What I do want to show you is that I'm going to start working on my new feature right away. I'm going to create a branch. I'm going to call it ChatOps because that's what I really want to show you. And I'm going to simulate me spending a few hours coding. I'm just going to change README to something else, right? Imagine that I spent like a full day coding and writing tests and so on and so forth. So I'm going to push this to Git. And we're going to take a look at what happens when I push something to Git, right? I haven't done anything that you're not doing already, except creating a new project. But everything else is just pure Git operations, right? And also what I'm going to do is that I'm going to create a pull request. Now, this is probably something you're not doing in this way. Doesn't matter how you create a pull request. Translate what I'm doing to you going to github.com or whatever you're using, clicking few buttons and stuff like that. I just like having commands for everything. So I have a command that will create a pull request for me. There you go. Okay, so my focus right now is on ChatOps, not on everything that we can do. So this is my pull request, right? Now, what is special about this pull request is that the system immediately, we're in Italy, I thought that you start complaining immediately when something is wrong. Okay, so the system immediately reacted back to me creating a pull request saying, okay, look, these are the rules that you need to follow. These are the rules that we agreed for this type of project you should follow. And the rules are very simple. It can be different depending on your use case. You can customize it. But in my case, the rules are somebody needs to review this pull request, and then it needs to approve it so that it can proceed further, right, to production. Simple rules. And if you don't know the rules, then you read them here. And in the meantime, it continues working and doing something. What it's doing right now is that since I created a pull request, it will run some automated tests and what's not, but it will also assume that I might need to validate my application manually as well. And what do you need to do? What is the main requirement when you want to validate a pull request? You need to deploy it somewhere. And you cannot deploy it to the staging environment or integration environment because then it would overwrite whatever was there before. So the only viable solution for you to validate a pull request is for each pull request to be deployed separately from other pull requests, right? There is no other way around it, unless you want to start destroying stuff done by others. I will let it work for a minute more or less. And but let's say that I will start communicating with my team. I might say, this pull request is urgent. Can you please review it as soon as possible? And I'm going to assign it to me, simply because I'm the only one working on this repository right now. And what will happen is that part of that communication is translated into action, and I was assigned to this pull request. You need to trust me that I wasn't there before I typed that comment. And while I was speaking, this message happened unrelated with me assigning it to anybody. And this says that the system says that, okay, so your pull request is ready, it's finished, it's validated, everything was done, and it's being deployed to a separate specific environment for this pull request. And if you don't believe me, you can click the link, and this is my application. This is we call them preview environments. Application built on top of that pull request and deployed separately from everything else. So, the real deal is that, let's say that I now went through all the hustle and said, this looks okay, I reviewed the code and took a look at the application, did everything I need to do, this looks great. I can say this looks great, let's approve it. And I'm gonna say LGTM, this is a geeky way to say approved. Looks good to me, right? And when I typed that message, what happened is that the system got back to me saying, you're an idiot. You cannot approve your own pull request. That would make no sense. And the reason why I'm showing you all this is just to show you that not only that part of your messages, comments are translated into actions, but they're also validated whether those actions are acceptable or no. So every action goes through a set of rules, and depending on the outcome of parsing those rules, one thing happens or another. In this case, says you cannot approve your own pull request. So that's okay. So what I'm going to do is that I'm going to unassign this, unassign it. I'm going to stop writing nice messages. You will see that I'm not here anymore. And I need to give it to somebody else. And for me to let somebody else work with on my project, I need to do a couple of things. And one of those things is that I need to specify in a file who is allowed to work with me. So I'm going to show you right now, there is a file called owners. And this is the list of all the people, everybody who can review and approve my pull requests. And if you pay attention, everything I'm doing now is only Git. I'm not really showing you any tools or anything. There are many tools running in the background, but from developer perspective, this is pure Git, just changing files and nothing else, and pushing them there. So what I'm going to do is that I have a second user here, which is, I forgot, this is my second user, Farcic. This is the user, previous one was my personal, this is my company user, just so that I pretend that I'm two people at the same time. So what I'm going to do is that I'm going to store that information to the owners file. So now my owners file looks like this. There are two people who can review, two people who can approve my project, and we can fix the problem we're having. So what I'm going to do is that I'm going to push this to Git. Actually, when I said push this to Git here. Okay. And one more thing that I need to do, and this is simply because this is beyond my control and depends from one Git provider to another. No matter what you specify who is collaborator, in GitHub you need to add that person to the collaborator section. So I'm going to add myself as a collaborator on my own project. And I think that should, let me see. I'm going to log out as me, and I'm going to log in as second me. There you go. Sign in. I could never do this without LastPass. This was inevitable. Brilliant. So, I'm back now. I'm logged in like Viktor too, like the other me, right? And while I was dancing, I assigned it to me by typing /assign Farcic CB, right? Farcic 2. So I assigned it to me. And now I can approve this pull request. And I can say, for example, this looks great. I will approve it. And what happens when you approve something? I don't know why is it showing me this. Okay, soon the pull request will be merged as a result of approving me. Probably it will take 15 seconds or something more. Okay, so that's kind of in a nutshell, and you can do a bunch of stuff. So I'm going to show you very quickly. I'm going to make a second pull request just to show you a few other potentially useful commands. So I'm just creating a second pull request. Nothing really new, nothing really special. Okay, so I created a second pull request just to show you a few other things I can show you. So, why is it showing me this header? I don't know. Okay, so first of all, this time, since there are 2 people in a project, I don't need to assign it to anybody. System will assign it to somebody. And you can see right now, this guy, Viktor Farcic, created it, and he assigned it to the second me. Automatically. The system is clever enough that says, okay, why would you bother assigning it to somebody? I'm going to assign it automatically. So that's kind of improvement. And a few other things that you can do with this. For example, I don't think we should proceed with this PR. I'm going to put it on hold. And then you will see a new label there. Do not merge hold. Or I can say, I'm going to skip writing hold cancel, and then it will be removed from hold. Or I can say close this pull request, and then it will close it. You can see from the top left or right there somewhere. Or you can say, after spending a night drinking with you, I believe you're okay. I'm going to reopen this pull request. And then it will be opened again, right? And so on and so forth. So basically, there is a huge list of commands, and you can extend them even if all those commands are not enough for you. You can extend it to do almost anything you want. In any form of way. The last thing I'm going to show you is my favorite. No pull request would ever should be ever created without a cat. No. I know that some of you don't like cats. If you like dogs, you can say woof. That's okay as well. And I know that there is always a certain percentage of you that don't like living things. So you can also have unicorns. Kind of, if real stuff is not good enough for you, you can have imaginary pictures as well. So we are all covered on all fronts on that, and so on and so forth. So that's the very, very short introduction. And while I was doing that, let me take a very quick look at environments. Actually, Jax get applications is what I want to see. So while I was talking, these are all the applications that are currently running in my cluster, right? And there is only one because I created one at the beginning of this talk. And what you will see is that this application, Jax Pro, that I created, is already having a release 0.02, and it is running in staging. So remember when I approved my pull request, it was merged to the master, and that started the process that deployed my application to staging without me doing anything. I'm just doing Git operations, nothing else, right? And you can, of course, configure it. It can automatically deploy to 57 different environments if one is not enough for you. So you can choose whether you want to promote an application to an environment automatically, or you want to do that manually. So you can say, for example, okay, production is set to manual promotion. I can say JX promote What's the name of my application? JXProw. Version is 002, right? And I'm going to promote it to production. Now, what this command does is that this command will not deploy anything to production, just to make it clear, right? Because that would break the principles that are used to base this solution. What this command does is the same thing as if you went to the... Now I need to log in as the other me. Wait. GitHub. How do you log in? Okay. I'll be with you in a second. The previous talk was about security, right? Anyway, so what that command saying promote to production did is that it did not deploy anything. What it did is that was only a helper command that made a pull request saying the repository that defines my production should have this thing there inside, right? So everything is based on Git. I could have accomplished the same result promoting to, let's say that I don't want to use any commands. I hate commands. I'm a person who despises terminal, right? Must be at least one of you. Some of you are always impressed by having something with a lot of colors. Anyway, so let's say that you want to have release 001 instead of 002 in production. You just change Git. Everything is Git based, right? Every environment is defined in a Git repository, separate repository for each environment, and then there are repositories for your applications, and promotion from one environment to another is just making changes to Git repositories, nothing else. I mean, a lot of things are happening, but not from user perspective. And while I'm talking, do you wish to use me as to comment on? Yes, I do. And now a pipeline is running and it will be deployed to production in approximately 2 minutes. I don't know, when does 5 minutes, am I 5 minutes over time or I have 5 minutes left? 5 minutes, questions? Trust me, it will be deployed to production. No need for you to watch terminal. I know that you dislike it. Do I have any more slides? Yeah, no, nothing. I spend all my time with open source. Please don't complain that open source is horrible without you making pull requests as well. My blog, my podcast, books, more books. And here you can find additional information about whatever I was talking today. Thank you, everybody.